Ones are good, some better than others.
It's okay. Just keep going.
This is Chan Hee Kim, his videography. So, like, if he offers to do your wedding, I just keep this in mind. All right. No problem. We have some bases to. We have to cover our bases today. Yesterday we spent quite a bit of time talking about acids and how we find the pH of an acid solution. Today we have to spend some time talking about bases. Next Monday, the next time we meet, you have a reading quiz, so don't forget about that reading quiz. Whoop! What's that? Yes, last one for this semester at least. We're going to be doing. We're going to be doing the reading quizzes about the pH of salts. Like ionic compounds, you put sodium carbonate into water, and it's just a normal salt. You think, well, this is not acidic or basic. It turns out that it's a base, and we'll talk about why that is, and you read about why that is. It's the conjugate base of some acid, so that makes it a base. And so we have that and polyprotic acids to talk about, and then that's it. That's it for the chapter. So we'll be in real good shape. I'll probably have to go into Tuesday a little bit with maybe our polyprotic examples would take us into Tuesday. But we'll have a lot of time on Tuesday to review and ask questions about what's going to be on the quiz. I did have somebody come in this morning, and they were asking a question about the homework, and they had, gosh, up into the 70s or maybe around 80 done already. So I said, wow, I'm so impressed that you had that much done. It's pretty easy. So, yeah, you'll find that it's kind of nice. It's not a very difficult set of problems. Now, there are some in the problems that I want to talk to you about today, so you'll see that. But grab a calculator, and I want you to try a couple of pHs of this solution. I don't think we got this far yesterday, did we? Did we talk about an NH3 solution? Let's see, we did this yesterday, yes? Okay. So now I got two examples of bases. Bases and acids work similarly, but the chemical equation is just slightly going to be different. So let's take a look here. What are the major species present? And when they say the word species, they're not talking biology. They just mean molecules or ions. So they use the umbrella word species. Are present in a 0.15 molar NH3 solution. Is NH3 an acid or a base? It's a base. Yeah. Acid formulas start with hydrogen. Unless they're organic acids, then they'll end with hydrogen, like COOH, if you remember that. Yeah, so nitrogen compounds typically are going to be bases, unless they start with hydrogen, of course. Like HNO3, of course, is an acid that has N in it. So just you'll get the feel for what's acid and what's base. So anyway, what would be present if we had some kind of a microscope that we could look and see what was in the solution? That's what they're talking about, the major species. There's water, of course. The whole thing is going on in water. But what other things would be in there? NH3 would be there. It's the base. It's a weak base, so not all of it reacts. What else?
H+.
There would be H+, but since this is a base, there's not very much H+, because take a look at this reaction right here. This is a base, the NH3 is. So as the OH goes up, the hydrogen always goes down. So that when you multiply these two together, you always get the same constant value as 10 to the negative 14. Right there. So the OH would be high, and that would be a major species there. The hydrogen ion would be a minor species, because there's a little bit there, but there's not very much, because the hydroxide went up. So we're going to say there's hydroxide. What else? Yeah.
Is there any compound that's strong enough to actually break the bond between hydrogen and hydroxide? Break the water bond?
Yeah.
So can actually make water dissociate?
Things can go in here and remove hydrogen ions, which throw the equilibrium off and make that go that way. I guess indirectly, that's what I'm thinking. What directly reacts with water? Well, yeah, when you put sodium into water, you know, it's explosive. That's because the sodium is trying to oxidize, get rid of its electron, and the hydrogen leaves the water and goes on to, it reduces. So yeah, I guess that's breaking the bond.
But would it go back to the right? Because it's an intermolecular bond between the positive cation, the negative anion and the H plus. So then would it actually do a reaction?
Well, yeah, it's a redox reaction. And it actually, when the hydrogen leaves, then it's left with hydroxide.
Right.
And so it builds up some of the products, and so the reaction goes back the other way. Yep. All right, so back to this. There's one other major thing that is present. And you should be able to recognize that if OH is produced, you're close. Somebody said, is that Wesley? NH4, right. Because this thing takes a hydrogen ion. Remember, it's a base, so it accepts a hydrogen ion. And so it makes the ammonium ion. Okay, now what I'd like you to do, these are the major species present. That's part of the answer. It says, calculate the hydroxide concentration and the pH of the solution. Would you take a moment and try to write the chemical equation for this substance in water? This is a base. What does the equation look like? Go ahead, write it down. The chemical equation for NH3 acting like a base in water. Yes?
On a test, should we ever say H3O plus or H plus?
Whichever you want. It's more correct to say H3O plus, but I really don't mind. You see, I'm always writing H plus, and so that's what I expect you to do. But if you want to write H3O plus, that's great. You're writing an equation. Yes?
Why is there OH in the...
Because this thing is a base. And when you put ammonia into water, its job as a base is to take a hydrogen in. So the water gives a hydrogen to the NH3. Now this is a weak base. Only a few water molecules will give hydrogens to it. So that's what our reactants are. It's water and NH3 exchanging a hydrogen ion or a proton. And so when the water gives away a hydrogen ion, it's left as a hydroxide ion. And that's how we get OH. Okay? It's from the breaking down of water. That's what the chemical equation is supposed to look like. The base reacting with water. Now, when we have an acid that's dissociating, we don't ever have to write the water. It's just the acid yields H plus whatever the conjugate base is. But when you have a base in water, you have to have the hydrogen in there giving it a hydrogen ion. And there's your two products. I said that wrong, didn't I? Did I say something wrong? You have to have the water in there giving a hydrogen ion away to it. So what we have here is we have an ice table. Because it's a weak acid, it's not a weak acid, it's a weak base, it will proceed to the right a little bit and then stop. We'll need a Kb value because it's not strong. And so the Kb value for ammonia, it's in the table on page 823. 1.8 times 10 to the negative fifth. Would you go ahead and do that? Find the hydroxide concentration, so this thing right here. Determine that, and then find the pH. Before I answer your question, I want just to remind everybody how important it is when you get an answer to a question, like when you find these two things, ask yourself, does this seem reasonable? Now you know what pH value should be for things, like acids should be below 7, bases should be above 7. Always ask yourself at the end of a problem, is this pH reasonable? Just keep that in mind. A truth?
So is NH4 a weak conjugate acid?
Yeah, anytime you have a weak base, its conjugate would be weak as well.
No, it would be a strong one, right? Because it wants to give away the H plus ion.
It's weak.
So it doesn't want to give it away?
It does, but it's not very good at it.
So then NH3 would be strong, right? Because it wants it back.
No.
So So neither wants to take it in, neither wants
So
to-
anytime you have a weak, its conjugate is going to be weak as well. Either direction. If you start with a weak acid, it makes a weak base. Do you remember doing this?
But what were we talking about after class yesterday then? I think Michelle asked the question
I can't remember.
about conjugate acids being and their conjugate and their bases being strong.
Yeah, if you have a strong acid, not a strong, I'm sorry, a strong weak acid. Okay, so we're not talking about the 6 strongs, we're talking about the weaks. If the stronger the weak acid is, the weaker its conjugate base.
Right.
That's what you were asking about, right?
Right.
Because of this thing right here. When you multiply them together, you get KW. So if this number's high, this number's got to be low.
Right. So you said something else. You said that if
That wasn't the same question that you were asking. You were saying if NH3 is weak, that means NH4 positive is strong.
and giving hydrogens away.
What do you mean by strong? Strong as a weak
Strong
acid?
Yeah.
Yes, I agree with that. I thought you meant one of the strong acids.
Oh no.
Yeah. I'm good. Get an answer compared to others. Remember, ask yourself, does this seem right? Using the 5% rule on this one? I think 5% rule is fine. Or is it? Or is it just a little bit above 5%? I can't remember. Is it 1%? Okay, good. So did you get hurt?
No, I don't know.
You don't know if you got hurt?
I was like,
Is there pain?
yeah, there's a lot of.
Well, you got hurt then.
But I didn't get hurt.
Just
It just like randomly just like in class and I was sitting, you know, like all of a sudden like I couldn't like turn.
The lower back?
Yeah.
You have a
Lower
spasm. That's a back spasm. Your
Not
muscles
lower
are tightened up.
back, not lower back, it's like right under my shoulder.
I bet you it's there.
Yeah, but it's happening since the morning.
We had a little drive-by action. Troy drive-by.
What did you do so far?
Probably not like something.
But it wasn't even in the morning.
You're a trainer, right? You work with Mike, your trainer? Little maybe massage. Good massage, you'll be fine.
X squared over.
Yeah, you're having try a little muscle relaxing cream or whatever. It might take a couple of days. I bet you. When I was young, a couple of times, I still remember I was a teenager, and then my lower back.
Mr. Moore?
Man, it really hurt.
Mr. Moore?
For nothing. But and then it goes. What?
Mr. Moore, was Amruth here for the 5% rule?
You weren't here for any of the equilibrium, were you? So yeah.
Yeah, so for that, it's like.
Wesley,
So
what is it?
So you just ignore that.
We didn't talk about KW yesterday. We had to. Autoionization of water.
What is that? Small enough to be.
We did. Wesley. You need to stay awake the entire hour. Okay, gang, can we talk about the answer to this? So the hydroxide concentration, shout out your answer, tell me if you all have the same thing. 0.0016, sounds good?
Now what?
Yeah. Everybody able to get 0.0016 molarity? You just do the ice table like we always do, x squared over 0.15, cross out the minus x, and solve. What's the pH? I told you, make sure that you check and make sure that it's reasonable. And what is it? Yes. Did you take the negative log of that number? And then subtract from 14? Yeah. Yeah. Then that, I was just warning you about that, anticipating you might have taken the negative log of this and said, what is it, like 2.8? Oh, negative 2.8 or 2.8, we're good, we're done. Not so, because this is the POH. So the POH, 2.8, right? And then 11.2 when you subtract.
Yeah, 11.22.